ಇದು ಲೆಕ್ಚರ್
ಇದೆ
ನಾನು ಒಪ್ಪಟ್ಟದ್ದು ಒಪ್ಪಟ್ಟ ಆಯ್ತು.
Yes, sir. We are able to see, sir. It's visible, sir. We can start now.
Can you make it full screen, madam?
So you can do it from there, your end only, sir.
Yeah, I have made it in my laptop,
Yes, sir.
but I think it is still not. Okay, I'll
No.
try. I am on gallery view and full screen.
Am I audible?
Yes, sir.
Am I audible?
Yes, sir.
Am I
You are
audible?
audible. Yes, sir.
Okay.
Thank you. Good evening to all of you present here in this lecture 53, distinguished lecture 53, that is being given by Professor P.K. Mishra. I'm really sorry that due to some technical reasons that we got delayed, but doesn't matter, we'll start. Now, so far as actually Professor P.K. Mishra is concerned, Dr. Kumar Mishra is concerned, first of all, I'd like to say he has been my teacher at REC Rourkela and also a colleague in IIT Kharagpur. Professor Mishra, born in Cuttack, 1945, and did his schooling from PM Academy in 1959, joined Ravenshaw College and graduated in mechanical engineering, BSc engineering, then we used to call, of 1966 batch, that is the second batch from REC Rourkela. He obtained his Master's of Mechanical Engineering MME degree in Machine Tools and Production Engineering discipline 1969 and PhD in Engineering Park Erosion in 1974 from Jadavpur University, Calcutta. His main interest lies in advanced manufacturing science, process innovation with design and prototype machine development, including developing new hybrid manufacturing processes and propagate the knowledge of microsystems technology in manufacture value-added products that changes the economy in rural areas. He is a list of others includes other achievements that include establishment of first non-conventional machining system of Professor G. Sen Memorial Machine Tool Laboratory at the Jadavpur University, Kolkata, with machine developed in-house through students, EDM, USM, ECM, and ECT. Successfully developed 3 laboratories at IIT Kharagpur, electrophysical processing lab, laser processing lab, and rapid prototyping lab. By designing and retrofitting more than 30 machines, USM, ECM, electroforming, impulse welder, electrojet, laser, ECD, FDM, etc. Developed a microsystem lab at College of Engineering, Pune, and advanced manufacturing lab and MEMS microsystem lab at IIT Bhubaneswar to inspire students for self-learning and developing innovative micro machines. Guided 12 PhDs, 63 masters, and 85 BTech theses, published more than 100 papers at national and international level, developed more than 47 machines, including 4 for industry, has 3 patents and 3 more patents are pending on micro machines in Pune. His book, Non-Conventional Machining, and 3 monographs, New Technology of Institute of Engineers, India, EDMI, Technology, and Telco, Pune, and Chemical and Electrochemical Processing at Bajaj Auto, Pune have been well received. Member of Indo-Japan and Indo-US Joint Collaborative Program on Advanced Manufacturing, that is micro manufacturing from 1998 to 2005, and 2004 to 2006 respectively. He is the senior visiting scientist to Masuzawa Lab of IISc, University of Tokyo, Japan, in gather experience in micro manufacturing, advisor to Mechanical Engineering Department of College of Engineering, Pune, recipient of following awards: Best Alumnus Award of REC Rourkela in 1981, Achievement Award of Production Engineering Division of the Institute of Engineers, India in 2006, prestigious AIFTDR Lifetime Achievement Award for his outstanding contribution to the area of manufacturing technology, design, and research, December 2012, awarded Elder Engineers of the State by the Odisha State Center at Institute of Engineers, India, Bhubaneswar, 50th Engineers Day 2017. He is a Fellow of National Academy of Engineering, Institutional Engineers, India, FI, Laser Association of India, and SAE-ST India, and member of professional societies like ASME, SME, IAST. He is also currently the INE Distinguished Professor. So he has got, and so far as actually is the reason is concerned, and inspiration is concerned, he quotes Isaac Asimov, which says the most startling advances have their origin in the boundaries of specialties, where the techniques developed in one field are applied with the fertile effect to the subject matter of another. If this cross-fertilization dwindles, the rate of scientific advancement will almost surely dwindle as well. And so anything that encourages cross-fertilization is all to the good, said great philosopher Isaac Asimov. With this brief introduction about him and his inspiration, I will now request our Honorable Vice Chancellor, Professor P.K. Nanda, who is present here, to say a few words about our university, and at least for those who are joining for the first time. Professor Nanda, please.
Thank you, sir. Honorable Chairman of this Advisory Board, Professor Damodar Acharya, and distinguished fellows and members of this INE Bhubaneswar chapter, and coordinator Dr. Renu Sharma, and all the participants. So at the outset, I must also welcome on behalf of our university and also the INE chapter, and behalf of all our IIT Bhubaneswar and IMMT and Niger and IEEE Bhubaneswar section, to our distinguished speaker, Professor P.K. Mishra today. He is very distinguished personality in the field of his mechanical engineering. About our university is now running 28 years, and from its inception as an institute, but as a university it is 18 years. And this year we have, in 2024, our university was ranked 14th in the NIRF ranking. And in the QS SCI ranking, it is 278, and QS World ranking, it is 1200 to 1400 bracket as a world university ranking. And also Southern Asia, we are ranking in our university 64 in QS. As far as THE is concerned, we are as a world university ranking, we are 800 to 1000 bracket. And our QS THC SCI is 300 to 350 ranking. And many of our computer science and health science program are there in the 600 to 800 bracket in the THE world ranking. So as far as the university is concerned, we have now this year opened one new medical college in Pulnakhara and hospital. And then also in the medical school of nursing, also have opened a faculty of nursing there, and will soon open a faculty of pharmaceutical science in that campus. Now we have added one more campus there, Pulnakhara, besides our fourth campus with agriculture, law and veterinary. So we have now 12 institutes under the ambit of this university offering in 10 disciplines, undergraduate disciplines, 72 PG and PhD, postdoctoral, and also MD, TM, MS, MCH, etc. And DSc and DLET also we are offering. So this is in brief about our university. So thank you, sir, for giving me opportunity to share about our university. Thank you very much.
Thank you, Professor Nanda. Do we have actually anybody from our co-sponsors, that is IIT Bhubaneswar, IMMT Bhubaneswar, Niger Bhubaneswar, and IEEE Bhubaneswar section? Of course.
From IEEE Bhubaneswar section, professor is there.
Okay, you are present. So you may say actually something you may say about your section, because later on actually you have to present the vote of thanks and handle Q&A. Would you like to say something about your section?
So Professor A.K. Tripathi sir is there to speak about the sections.
With this, I now request.
Thank you,
Yes.
Dr. Acharya, giving an opportunity to IEEE to tell a few words. In fact, I know Mr. Misra for a very long time, and in INA platform, I had the opportunity to listen to a full lecture by him when he was honored by INA. And there is no doubt that he is a tall man in this field. When I heard the topic, an ounce of practice is valued more than tons of preaching, I was wondering which sentence it can be. And today I see the picture of Gandhi and tell that no wonder that this man is behind it. Anyway, talking about IEEE, I am very proud that recently we have elevated ourselves to a section, full section, and due to combined effort of every executive council member, and we are one of the good sections created in the eastern part of India, and we have also taken the kind of a vow that we will see that this will be one of the best sections in the country in coming times. Already very competent people are in position in IEEE Executive Council, and I'm very happy that a team of people very dedicated to different verticals of technology, including electrical, computer science, devices, telecommunications, computer, and everything is fully taken care of, and IITs and your university and KIT, including Silicon, are taking the lead. And we also expect that those organizations who are not so active also will be pulled into the basket, and will also spread geographically all over Odisha in a couple of months. And I think this is a very good attempt taken by Dr. Acharya and Subhranshu to combine the activities of IEEE, INA, and Niger, and a couple of organizations looking into a research area to have this joint series of meeting. I am not able to see many faces in these meetings because of diversity of subject. Some of the subjects are beyond the understanding level of some of the people, so that's why no wonder that the attendance is not so big. But even if it is communicated or conveyed to interested people in Odisha, we are one of the best IEEE sub-branch led by Dr. Acharya, who is at least doing this function with 53 lectures on record. And I am very proud to be a member. I never miss this lecture unless I see the topic is almost beyond me. So thank you, Dr. Acharya, for doing this. And you can include some of the IEEE veterans also into the faculty who are invited for lecture like you have done now, Mishra, and local people. I think locally we are very strong here. Thank you so much for giving a chance.
Thank you so much, Tripathi sir. Now, I will request Professor Mishra to make his presentation.
Thank you very much. I am Professor P.K. Mishra, and now presently I am out of service. Now I work for the society. Like my favorite topic is an ounce of practice. The valued more than tons of preaching. It is concerned with the teaching because my childhood, since my childhood, I have a dream to develop our own state. Own state, nothing but by India, into as equivalent to any other country. That was my ambition. As a matter of fact, when I choose this topic because the death of Mahatma Gandhi was when I was entering into the school in Pipli. There is a place called Pipli. My father was accompanying with his old, what you call cap, British cap to civil engineer. He was using white shirt and white pant. I am wearing khaki pant, and I'm also wearing a khaki, of course, with a galley, because I was very small. We went, that was in Pipli, there is a school, original school, is a Christian mission school. We are at the gate, and all were stand or waiting. The Mahatma Gandhi has died that day. So, because as father immediately I've seen, he has thrown his cap outside and started crying. Then I realized at the age of about 3-4 years, I was puzzled because I was the middle son and I was taken care by my father. And I'm the only one engineer who took the service of engineering professor, chose the engineering professor. So I always from the childhood, as the middle child, I was never accompanied by any of the family members except my father, because I sleep with the father. And he's my actually the guide for me to push the society. So I started thinking about Mahatma Gandhi, because that is why Mahatma Gandhi, I follow the Gandhiji principles. My father used to worship him as a god. And from that onwards, I have taken the principle why Mahatma Gandhi is so much there. I realized that after reading, I chose, he's the father of the nation. My father is he has given birth to me. Okay? And my mother has given birth to me, but I follow the father, because middle son is never the mother's son. He is always the father's son. Because mothers generally they choose the elder brother as the family members. Anyway, so I was following always the father, and that day I chose this subject. What do you call this thing? Mahatma Gandhi, as a Buddha has said, human body, the perfect man's body, mechanically does the right thing. It can do only good because it is fully purified. Human body is fully purified. but we change it on the situation and the personal profits and all these things. But if you think logically, the human body is always purified. That is why we should have IQ, EQ, and emotional quotient, spiritual quotient has to be attached to it, and it can do much more better performance than. So actually, first thing, when we start thinking of this thing, how I have been brought up, I will take into this picture and say why I practice more valuable than what you call the terms of preaching. Now I'll on to the next slide. Now let's say when a child is born, he has to be fearless. So my training was that as a childhood, in the time, I was always waiting. It is in, I still remember that place. My father used to come back from the field. He was a British government servant. So he comes back at about in the time, and he starts, and you can see palace. So I used to wait for my father to come. It is in Barampur. It is in Barampur, and I used to wait for the father, and a tiger always comes and sleeps on our veranda. I used to go to that one because because the tiger sleeping, and I used to talk to him. I used to throw initially. So the tiger used to soundlessly sleep. Soundlessly sleep. Sometimes it's just like what you call the dogs, they do. They love the children. Tigers also, they love the children. Because, and that's the fearless, yes, tiger is not a fearful thing. If you watch what you call this thing in Discovery Channel, I always watch that beware of animals. Then you will see that the tiger is not a dangerous, but they love the children. So I was here from there. My fearlessness started from that one, and then I see how my mindset was of the Chinese built. I remember during the construction of the Hirakud Dam project, I was accompanying always to my father. That was time that was in Hirakud. I still remember. Thirumal Iyengar was a chief engineer, construction, and the next one is our. He is the dam constructor. He was in the charge of the right time. Okay. Anyway, so I used to see, and Thirumal Iyengar had a very serious problem, what is called rabies problem. Wife was sorry. I used to see they used to dump huge amount of what you call this thing. I used to stand near the head and watch. There's so many blood and all this thing. But constantly, why so much blood is coming to this thing? I asked my father, nah, you see, Thirumal Iyengar's wife is suffering from what you call rabies. Anyway, I used to see that one. So gradually I see human life should not be, is considered in such a way, we should not fear. Anyway, so similarly, so I bring back fearless to anything which comes to me. And there I observed when my father used to go for his office around 9 o'clock or something, So he used to kind of come and jump into my jeep. So I used to sit and move. And on the way, if you see that some dozer, bulldozers, or tractors, anything is like idle. So you should go and play with that thing. I don't know. I used to go because I was very curious about the machines. So I used to play with the steering wheel and try to see how this steering wheel, what is the function of this one. At the age 3, I used to see how the caterpillar is moving, because caterpillar and all this thing came later on. So when I am completely tired in the sun, they used to run down the thing. Then I watched the stream which is flowing in Mahan river, and then see the turbulence, because I used to make the paper boards and try to, then it goes to pull and see it is rolling. Then you see how this type of thing gives the inclusiveness to know more about fluid mechanics. Then later on I utilize that fluid mechanics into actions. Anyway, this way I was trained, but I became fearless to do anything, whether I cut my finger or something. And in the process now, at this age, half of my body is replaced by many components. I have donated something also, and I'm still fit at this age, 81. Officially it says 80, but I'm 81 crossing. Okay. Anyway, so I am keeping myself fit as far as possible. So that's why you can remember I've taught given the word of Buddha, and let me come down. Schooling, as I already told, and let me come down. And this is the thing on the basis of which I've taken the what you call try to prove that Mahatma is teaching how to be taken into practice. I'm trying to give in the word. This is the philosophy of my future achievements. Then I come to start my, because Professor Acharya has already given my introduction. I first joined RSC Rautla. Since after 1 year, I was switched about to Jadavpur University, and as a research scholar. And after 1 year, I was directly taken as an associate professor, because while they found this person has a potential something in teaching, so I started teaching in Jadavpur. Since then, all the things started. So my thing, the first message which thing, where the vision of setting up a GCSN Memorial Laboratory at Jadavpur University, and to start that on, we started developing the machines. Now, what sort of machines? Now, we started, when I entered, they found that big the thing was, you might be knowing about Tapan Ghosa, who was the right hand of, or Abdul Kalam. He was the right hand of this study. He was starting this EDM machine. When I entered the our machine lab, I saw it is in the study, but it was trying to do with the hand feed, because automatic feed was not introduced. They made a structure. Then Tapan Gosal is my classmate in Tapan Gosal, please help me to develop it further. But this was, by the time we have completed our, but we were doing our masters, but Thomas Goswami was helping me from electrical engineering side. And we started this one using relaxer generators, because that time all the machines were with using a relaxer generator, condense the charging, energy discharge, a minute lightning is called. Because I'm not going to theory because that's separate issue. And then we developed this one in the form of a machine, and this is probably the first machine I can say in thing. And HMT started collaborating to this project. They nothing. They provided near about 20 lakh or something to develop further, and that with that one we started developing the second machine. Year-wise, it is the third machine. And later on, because I would slightly changed the topic, then that was the thing. This was the first machine I've done with the collaboration of the electrical engineering department in 1971. I'm not telling them, I'm going chronologically what is the thing, because we have to develop what you call, for this type of science, we have to create vertical manpower for teaching. So all the research scholars were associated with it, and along with them, the PhD teachers, they started doing PhD on that one. But PhD, they have not started unless they know the machine. So we developed the first machine, and you might see who are the scholars. S. Circle started his master's, he did it, PhD, he went to collaboration with the science stream. Because the idea is we have to, instead of individual approach, but we have to interdisciplinary approach. I try to bring in. So I try to involve many things and develop this machine, the same machine, because the same machine is a powerful machine. Now, this is one of the things what I'm thinking, what should be the futuristic machine? A futuristic machine, because all the biological plants or any modern machines should be stress-free and crack-free. Then the life or precision can be achieved. Otherwise, we cannot achieve the highest precision, but we are still yet to touch the precision field. Now, what I am in the future plan, if somebody works with me, I can help them to develop that type of sensor. We'll come to that one later on. Let me proceed to it. Then simultaneously, another MTech students I took who led to the PhD. And that time what happens, when you use a relaxant generator, Japanese people, especially the Japan scientist, Motoki, if you ever remember, it's Motoki, they experimented with 64 relaxant generators. And still then, they found the tool where it's higher. It is what is the spark from the cathode to the anode, and cathode wire is there. Because when there is the electron they take out some of the particles from the cathode. So that means the generator, like you say, pick pulse. Sudden discharge is there, and then it starts contributing after ionization, it starts distorting. Then we changed over to another conception, because that time my electrical group came in. I can say the Rana Dattagupta was my classmate. He is we call him as a human brain, human oscilloscope. Because I can say, what is this? He puts his oscilloscope and put a plug somewhere, then say, okay, you change the NF component. With this one, I will give an example how this, what you call, signature analysis works in the design. I give a thing. General Motors, one of the best motors what America has produced. In General Motors, there was the inspection was done by one mechanic. He used to take his salary in the common prison, which his salary is more than the director of the company. And what he used to do, in the bed, I have not seen it, but I have read it. And I've also seen the what you call popular science, discovery science, that has shown how it was done in the old days. Generally, we don't watch what you call this thing, but I always see discovery and get the ideas from Discovery Channel. Anyway, so this was created. Then we see in electronics, because he was the design for the Isuzu computer, which is the first computer in India. Isuzu means Statistical Institute and Jadavpur University. The first computer was built in Jadavpur University. And this computer, then it was what we wanted to go to the field of electronics, because if you walk the what you call transistors in the switching mode always, generally in computers they work on switching mode, and the rise and fall time says how much heat is. That is a different phase one has to do it. And then what we designed? We designed just a what you call a power transistor switching mode, and try to adjust the what you call best current to stabilize the pulsar. It is just a square wave generator with rise and fall time. We have to control rise and those are much more complicated things to be analyzed further. And then we see that time also this was not developed by IIT Kanpur, but electrical engineering department tried to develop what you call the electrical generator in electrical generator. But this principle was not started by electrical engineering department, because computer department was something different. Because here you see the education system is something disturbed, for which I was disturbed, because we don't have any collaboration. Why so many departments? What is the purpose of it? Because I'm a manufacturing engineer, I must comply to all the people, whether it's electronics or mechanical or chemical, everything I have to comply to their requirements. So I can't say I'll take a lathe and try to turn a thing. Okay, that was the principle what Professor Bhattacharya has told. He told Mishra, you take over this. Then I started growing up this section. Then it was shifted to one by one. We started shifting to what you call this thing. This is why I'm telling this thing. Individual research will never survive. Cooperative research is required. One man cannot do a thing because one man can do it wrong. You should have an assistant who can point out this may be good. Let's take the students. If you choose the students, their involvement will come so that their ideas are, because they are much more educated than what we are. So that's why we took up this form. And then Charles was trying to develop this form. Then I met them in one of the conferences in Kyoto, where the Charles, which is the number one machine in US, their professor Stories and Father Peter was there from Zurich, Merchant, all these people were there. We met them in Tokyo. We discussed all these things because though I was young, they used to put the hand on my hand. That was my blessings. So I picked up all these things and tried to implement them in this business. Anyway, then I started thing, this was developed. And further, you see, we have tried to measure, capture the picture of the spark in the previous one. Picture, here you can see all the everything. This setup will measure what is the best current, how much is the frequency, what pulses are taken by the system, which are rejected. Everything is counted here. We have downloaded this particular in it to measure, capture the effective pulses. Then you try to model them into by graduate weighing how much material has been removed. That's how we try it. Then actually suddenly this problem we try to develop. It has that the industrial link I have seen in the Union Carbide in the previous model. Union Carbide jumped to us. They want to manufacture a drill a hole in stellite. I told, why stellite you are using? Now it is extruding. Now why how you are doing now? They told they were importing. Now you are importing means you have got a lot of money. Go ahead. Why this one, this one? Now I told, can you machine this one? Well, I can give you the accuracy or precision part of it. I said I will drill a hole in stellite, which is not possible in a what you call conventional machine. But we don't have a tool to drill a hole. Otherwise, diamond drilling has to be done. It is a useless process. Anyway, so I showed them, yes, we can drill a hole. And the Andy was standing and saying, yes, whether I'm like that. So that's all that is still. Then, can you give your machine with develop? No, I cannot develop the. I can develop because if you see you want to produce something, I have to explain. Unless it is completely successful, I can't. However, you can take the designing copy and do it. Try your. They didn't have a research section in manufacturing at the time. So that was a good thing. How to minimize it was separate because there's a lot of wear on the both sides. So what I did, okay, this unless I consider the rise and fall of the spark, it is not possible to control the. So to develop to control the sparks, I developed this machine, and this I can't do because I can develop all this structure. What you can see, it is all the students they do because we had a beautiful vertical manufacturing shop known as Blue Earth Workshop. It was the first of its kind in India because you see that time the manufacturing activities was done in particular Calcutta. Subsequently, there are all these political problems came. They start still the structural complex was the thing. And another thing, how to build the machine, we collected all these parts from the junkyards. Junkyard means I don't have money to buy. So I go to the scrapyard and to collect what you call the Boeing. Or you see, if you Calcutta airport, Terminal Airport, it was open that time. So we used to even take out some of the parts. But subsequently, police people started chasing us. So we went to Tanzania. There is a thing in Calcutta, you know, Tanzania, and there is a Malikota. These are the places you can get anything. If you want a dead body, also you can find it. It's such a thing, I'm jokingly telling, but you can get anything other than. So we used to go there and pick up what is A. It looks like a structure, you can say, but this structure is not manufactured. Previous structure was a drilling machine. By the old machine, something we get in the machine itself, old machines in the corner. We used to bring it and make a pillar type thing, everything I converted to pillar type. And I did the smaller ones because future trend is you have to make the parts smaller. So we tabletop machines started to and try to develop. That was the idea of making prototype machines in any institution. Then subsequently, I had a problem. Another scholar was that he was MTech, he completed MTech, because in the same machine, he has done completed and done to a PhD to put what is the very part of the analysis of the stock in the whole, we call it machine. But I found this machine is a superb machine. It can be used for anything. So that time, it has got a long history. I don't want to tell the history. When we discuss, sometime anybody is interested, you can discuss how to download. This is that time, Bullard was the only machine who did what you call this ultrasonic drilling machines for wafer drilling. That is done by the Bullard, only company. And Bullard charged, I told I can't buy because they charged about 8 to 9 lakhs that time. But our department runs with 2 lakh. I asked them, Gopal Chandra Sen, because I was just like a son to it. Anyway, but that was what my Gopal Chandra Sen, that much more allude to that one. But we have ministered the one from this one. So this machine told why this why you found something wrong. This is a metal-restrictive transducer which is used. We take the Sankey, manufacture into a transformer, and we put that on in electrical department. I didn't do it in electrical, but I myself I tried to wind it up because we know winding in mechanical than anybody else. So I did this one, and this was we took. Let's start working because it is largely why I checked this one. Everything is done. I have not to hire the patent right because they may charge because who are Indians, company. So we are afraid. So we started developing ourselves, and especially we did everything, all the parts. Because this is a thin, long pillar because we have to design this person up to the level of the engineering. This is the new concept because when we develop a machine, we have to think of the wherever you're going to start. Because the mentality of the people are different. In India, we have got so many varieties of political people, and sometimes somebody likes it doesn't happen. Don't like this because this is too hard. Somebody will tell, okay, it is too much tough. I told, okay, let's make it up and then to a level on this side because ultrasonic radiation can be destroy anything else. Because we have felt while developing this one, we have a different sensors on the wall. We don't have the sensor to measure the frequency and this, but we have to run the machine. First, then only we can proceed with the experiment. So you touch the key. There is a high frequency because human can adapt up to maximum. Ladies go to 15 kilohertz. Human. Ladies can go up to 27. Because you see, this depends on the light. They don't. Ladies, they don't like to hear the high sounding word from the husbands. They will take on sitar. They play with sitar, guitar, and all this. They produce high frequency notes. So we can apply that one, change the mindset of ultrasonic later on. Now, ultrasonic is a big field which should be applied to medical science. You can do the what you call, my feeling is now at this stage, you can, the mutation of the genes can be easily manipulated by ultrasonic because you can image everything. You can also join this one. There is a thing. In the USA, if they is a fracture, they can, any fracture in the leg, they have to wait for some 6 months, 7 months to go to the fracture. In USA, USSR, they take only 2 days to make a athlete jump into the field. So how? Then I had a book called Ultrasonic Vertigo Force. If you have got a fracture or anything, knee surgery, you directly use ultrasonic. You can treat the arthritis person. You can imaging, in medical science, imaging is technically always used. In imaging technique, the drawback of this one, you take your positives. If there is something wrong, you think that because when it's affecting the human body one place, it must be good for that. Our 5 fingers give 5 senses. Okay, and God has given us the 5. So everywhere there any research or anything, we try to give 5 fundamental principles on which this thing. You can see human body, I am telling you, what I'm feeling, I can, oscilloscope, I told you as an example. I get an electrical shock. See whether actually it is harming. What is the voltage? We know that if you are above 50 voltage, we have to proceed because it is taking too long. Anyway, you can discuss. If you have any questions or anybody, then I'll give you a reason. I want the younger generation to be prospective and futuristic and WD Coming to another one, this is a lead we have developed. It's not an ordinary lead. You see, we are using this problem of a heavy engineering corporation. I took that one, balance. So he did PhD on this and take the PhD on this one. The topic he chosen for Manapal. Manapal was the first MTech students. Manapal, I think you must be there. And then we did it. And this is the thing. We are using high carbon steels, high carbon steels or tool steels as the rollers and then try to machine them. But this is not, we should give only one because you will not get the accuracy. If you have some process, you can direct the machine, the rolls, and the farm will give the component in one go. So this is less we can only machine, we don't have a trust machine components are reduced and you can do, and the surface is stress-free, crack-free, which is the requirement for a rolling. So we did this on a small type because we can work on experiment with a form. This can be taken to any size depending on the job size. So we are thinking, we buy one machine, we try to develop all the components. You say finally you cannot sell them. Demand comes as when it is required. So you machine have to see, because typically you find in certain phases, certain components have to be manufactured. Not all the components. So the concept is that one, you design the length and make, you see, this concept I have taken from what you call the Punjabis. You might have seen Adda length. Adda length means you gossip and manufacture because the dhabas are there. So on the roadside from Hisar to Hisar to Delhi. So that road developed the Hisar lane. It is not other lane. Components are for side. They know the sky at different places, the different component falls out. Say they that type only. No cross feeder. If being that one, the retest it and bring it back because they will take a bottle of 1 mile or 2 mile of desis or whatever drinks they will take and take those chapati and like one thing. I have seen, I have visited them and see they call it okay. कितना 2 मील 10 100 मील का दर दीजिए 100 किलोमीटर 200 किलोमीटर the drink is for the kilometer basis because they drive that long then at the end they'll go to another dam वहां पर खटिया का ऊपर सो जाएगा then they will go further. Oh, these are different concepts unless you go outside mixed with the people you can never realize the problems what are there and what type of message you have to do. You see, that's why Mahatma Gandhi has told, before you do anything, visit the places, see your people, what their need. On that need, you develop thinking. That will be a locality. If you manufacture somewhere in what you call Punjab and bring it to what you call Calcutta, you see, by the time it reaches, it's local or something. So, why the do a thing, wherever you place it, and you replace the part and let it go running. That is another concept. Okay, so these are to be done unless you visit your own people, visit your own people, because you are maybe finding problem in teaching Odia student or Bengali student and or a South Indian students. I find that the African ladies are moving around. So their ideas are different. So you have to think of a system which can serve to the people or anybody, right from above 15. Because engineering or anything starts after. Here I want to say a thing. Praktitu is a Lalai Panchavarshani, Dasvarshani, Tarai. Praktitu Sorusa would say, Putram Mitram no. So industry, India Technical Institute, people are coming after 50 years. Because they're mature. In Odisha, not Odisha, we are everywhere. If a child is crying, if a male child, mother will not hit. If it is a girl child, the people are hitting. This is the psychology. Why do you have to treat like that? Why you are not seeing what is the problem? That is solve the problem. Anyway, I don't want to, that's a different politics also with a different. So the concept has to be changed. So this is the one thing. Then I started this very interesting problem. I solved for EMC. I don't want to name who EMC, which is one of the top electrical component manufacturing in Calcutta. EMC, electro, the mechanical, but something, EMC. I don't want to name the person. And this was gone into a problem when there was a fight between CPM and Congress. Okay. All the companies were having, what do you call, some political, anyway, I don't want to discuss that politics, but then I told I have to leave Jadavpur University, I want to go to, I've given the year that time, silent at that point. I want to leave Jadavpur University, better, let me go to, because payment of teachers are much more less than the students. I mean, time. I've gone, anyway, I've gone up to 13. Oh, I have to speed up. Anyway, I'll speed up now. Now, this is a different type of machine. I find this is the very cost thing. Problem, what is the problem? Workers strike. Okay. Job what they are manufacturing, electrical hook, they are manufacturing. And tensor wires are manufactured by somebody there, and the hook up thing is a really hard thing, which takes of the load of the with everything. So they were manufacturing and their particular towers, they were towers they manufacture, and they want to manufacture that one that is done by a milling machine. Then they were slightly paid because again I don't want to use the name. Okay. So they told me I went to they have got an research manager. I applied for the research. Finally, they told me you have to come to. They give me the offer. You come as a box manager. Actually, I want to block them. You do this thing like this. I wanted to block. Then they told, okay, so you join. What can you join? Well, I have to give a notification for more informant, sir. In that way, we have to give at least 1 month service notice. Now, if you can't join, you tell me who is objecting, we will do it. Because they are political things. Then the fight came between the same division because anyway, again I have to go. The two parties are the same group. And okay. They have had a fight. Somebody is telling how take him, sir. Another person is telling, yes, I will take him. So then I sat with folded hand. I told them, okay, leave me. I will go somewhere else. Then you see, then my change started because it was a political fight and affected to a non-faculty faculty, only one number one, and that too, I'm not a, what you call, politically affiliated to any of these two. Bengal and Dhoti. That problem is there in Calcutta. So I told him, better say, but my friends were my students and sisters. UG students, because UG students in my class, I'm not posting. Please don't that I am posting. All the people, whether it's their Noxals or DSO or anything, everybody started liking me, everything. That time also I was well. Anyway, pretty handsome, and everybody started liking. From the opposite sex to everything, they started liking me. Anyway, but I want to go away. So then, see, first thing, I went to a lecture. That what is that? That's the first, I call it a logic control system. It is nothing because any motors, they work on a fixed voltage. Fixed tip. So I taken a actuator, which is can be programmed on and off is programmable. So name was the thing. Then I told it's a horizontal thing. I want to get out of this thing. But first, apartment was given when I presenting this paper. I've never published anything excepting 3 or 4 papers in ASME and this thing. I have not published anything because I want to take the patent because patent act we can't do. I am not going into the what was the trouble in because I was asked several times, why don't you patent it? But as you know about what are the patenting laws, and Professor Acharya will tell how we started patenting. He is the first person who introduced what you call IIT, the patenting system. Okay, then what comes here academic says cognitive section, how it effective and not we have never analyzed those things. Anyway, so first offer was given while presenting that thing where Professor yes, IT principal today. He came because he is the director. He around my whole system, give you time for 15 minutes of your time presentation, and the fight between the assembly person doctor, Gangapata, and myself, we went into altercation. Altercation, he's telling, you don't know, people, we don't know how much force you want. So like, what forces, how many force is it? I measured the how much. I put instead of hand, I put what you call balance, linear balance here, and one rope there, one there. I tried. Okay, how much time it takes? Okay, it takes about 4 to 5 kg, which I can be. Okay, so on that thing we argued was that then we stuck because Professor Sampath, not something that time anyway. So they gave me the first number and put. Then the problem started how to get in a Indian. Anyway, so then this is it. So I've used this code from this thing. This is repeating this one. Then immediately, Bombay, I want to go to because that tussle was going on. How can you improve? Director doesn't have the power to recruit from inside. He can recruit it. So there was something, Duppad. So Duppad was other thing. He's not only, he's not Mishra from Kanpur. He's Mishra from Oriya. He's Oriya Mishra. So the problem started from that one. So that type of problem still exists in our system. It has to be removed. Okay. Then, but it's a Bombay IIT. I went to go Bombay IIT. That time, Bombay IIT has got different problem because that time BD Nath has taken over as the director, and he was working with me in CNC control of machines in Jadavpur University. Okay. BD Nath, but he didn't come to take my interview. He certainly the Bombay IIT was prepared by that time. Most of the Kerala were there. Okay. And Maharashtrian people want to drive out this thing because then you see the what you call local problems start coming in. So that's the thing. Finally, I went to what you call. I got selected there by one of the hydraulic man because he liked me very much. Professor Carr. He is hydraulic. He is a famous what you call hydraulic. He started putting me questions on hydraulic because he told about, have you known about the water studying? Yes, I know about it. I teach that one to students. Then, never travel, but I will do and develop the water cutting. He's a hydraulic man. How can you do it? We went to do this. So I simply, whatever I know, I told them I was selected. The problem came from my home. So I shifted to Kharagpur, which is nearest to my home. Okay. So Kharagpur, then beginning of the, now, but his home is there. My wife wanted to come to what you call nearest to our parents. So I told it's better to, but still, though I had the feeling, because the conference what I have again in Jadavpur, I can manage in IIT Kharagpur. So I came to that one in IIT Kharagpur with, because I was the leader there. There is some problem in taking me as a professor because they don't, IIT Kharagpur doesn't recognize what they call Jadavpur University in mechanical. Because there are some problems. Oh, anyway, I don't know. So I came to IIT Kharagpur. Then the problem I got from what you call or hell, drilling a hole inside the thing. You can say we developed this one by the person. He finally this called star. That means technology, electricity. Because chemical people don't want. We know some level where the what you call finance laws are valid. But what is beyond that one nobody knows. Because if you see the charging cycle, is suddenly go to a corona zone and try to go. You see, current user, you see, energy level increases. Using that principle, we take the electricity and put a high voltage through the electrode, and that just goes and try to drill the machine. And finally, the same person, okay, Ramarao, I still remember, he, I think he became the, Ramarao became the AGM, ARTC, Halbanner. He's still in contact with me because Ramarao still loves me as his father. This machine is a new concept of machine. Okay, you take any electrolyte to the corona space and use the combined principle of electronic stuff and chemical. So hybrid machines, you can drill holes, and then he went there and replaced all the team of what you call machines to their own developed machines and drill holes in different. Anyway, this is another thing which is done by what you call one favorite spirits on the south. So how do we can join copper to steel? We can join also you can use different materials. Generally we prefer materials should be same because there are so many disabled of building. But this is the thing. In the electric components, we find that there is a graphite, and you want to join a copper to this. How can you join? So we took the principle of discharging where we try to do a condenser. You can see a condensers are there to a high voltage, and try to put this one, and you see when the spark gap is equal to the discharge voltage, it will discharge. Penetrated, copper penetrates into then solidifies. It is a electrical drilling process plus a vertical Becquerel law, and then so this was done by the. Then he left that one. That one went for this development. He got admission to what do you call? Caltech. So he went there and this was done. Then, you see, the previous ones, I was involving what you call the teachers, MTech PhD. Then when I come to this one, I got a plus point. Plus point, I had a careful, we have the electron set. Tell me, you can drill a hole even in diamond. Diamond. Anything. This is the thing. If you take above 1 Mach, it becomes a thermal process. And if you below 1 Mach, it becomes anything with our Excel machine. And the machine thing is your machine number. And we designed this one according to the Lloyd's principle because in technically all this thing you have to lot specific follow. We have done all the design was done according to any standard. Where it is done is our own, and there is a certain principle. I don't want to disclose that principle, which I learned from the Japan. And And then finally we went to another thing. We are giving a coating. How to find the hardness of the coating? So we found you put what they did, a diamond tip from a mineral hardness is not with the rotor hardness tester. You see, it has got a cone. That's a triangle. Now there is a transducer which you touch it and touch this one, see a hot lead because each has got a sensor. I will load everything is measured. Then you put it, when you see it, with a microscope, you see white line is seen because over aluminum or anything you deposit any material or gold or something, which is fairly big with gold, because gold coating is required in any of the electric. And with a fine thing passing on some electrical connectivity, we can do it. But we have to find the resistance between the coat, upper and the best coat. You can take that one measure what is the voltage. Anyway, so these are the things which I should develop in IT. Then we had first the ECM thing. Here we have completed PhD, masters, and all these things. And it is a machine which, whatever it will cut at the higher feed rate. And this is we connected a computer which gives the feed control. Because when there is a isotope is very near, then there is a spark, and this computer can take out the spark and control. Anyway, this was. Then we started knowing where it is. What is called rapid prototype. People are thinking of the rapid prototype, but I want to go for rapid prototype meta. So what it gave is the machine. And this was the Russian machine which was lying in the junkyard. Hangar. So then it was not in metal science. Because our Madhusudan Chakrabarti, he has got the scanning microscope. Because this came along with the electron microscope. And at that time, I am interested to take that on machine. There is a machine. That time I got a severe accident with a plaster on the right leg because I lost my knee during that time. And I used to sit down always I do. So I opened out everything sitting. Sometimes my research scholar will meet me and put me on the seat and work on this. Then the problem was that everything is all right. Because there I first saw hydroton control. Russians are using hydroton control, but we have not reached what you call the ordinary, current devices. But Russians were using. I found that machine was with hydroton control, and the American researchers will see SME or SME transition to C, all are transistor. But they use the bank of power transistors and are controlling the current. Anyway, we repaired that one, then it came. Then what problem is that wire is not going to the guide. We distributed that one so that we make our own spool, because spools is another question. We have to, Indian spools, spools will not go to the same. So we developed that the spool now and try to load the wire with Swil in Calcutta, Sullivan Wedgewells, that company, and they load that one, and we use that one. This part from the experience with the wire here. That is where it started. It's a peculiar control copy because they have got a the jump and where one electrode and the other electrode, and it goes inside, cuts that. Okay. And for this one, they have a very beautiful, it's a copy filling. They use one or two condensers and adjust the gap. Anyway, we did that one retrofit machine. Because that's why I buy others. If you got a machine, they will throw them. Allow them to, but the stewards use, you take out and do whatever you like. That is innovative. Because I got this concept from Kandimanan University, because they have got a day when they celebrate, they will pick out a car and then remove it, junkyard, and put it, and they run. Okay, and that concept I told. That's why I told that in your street festival, introduce some of the companies to demonstrate how to assemble. Anyway, that's a different thing. So there is another one we started. Anyway, let me start. These are the machines. This is the arithmetic machine within the PLC thing we started doing, because our entire body is an electrolyte. So we can use this principle to print inside any component, anything, any metal deposition or anything. You can also gene fusion, gene mixing, because on the principle, and this was another thing we developed, said that we're scrapping what you call the grinding machines. Is very costly. So what do you think? Why it is not giving up? But when I'm clear, get the problem. Change it up to okay. So we start developing any machine, contrast machine is scrapped. Then you use what you call retrofit machine to hydraulic grinding. Mechanical grinder with hydraulic fit system, and we turned that on. This led to it was what you call appreciated by Magov told no further writing. Okay, was not required. He has done a system which is working. This should be our. That in Magov, you might have known, is a what you call royal family. Anyway, next one is the with Professor Amitabh both. We started because they felt their project was given to IIT Kanpur. They couldn't. They couldn't. So they gave to okay. Then they got some high amount. I told when can I get a fund? So he told how much you take? They got a you think, nah, give me 5 lakhs. No, okay, 5 lakhs. I will give. Then when they went to here, on that 5 lakh transfer to IIT Kanpur, IIT, what is the reason? IIT Kanpur told nothing. We can't give a single penny. Let them get it. So finally, I asked them, I want 5 lakh, not obviously. When we submit a project, we see much of money. I become 5 lakh, I can manage it. Otherwise, I can pay something from the pocket or ask the student, okay, you find something, we do it. So with 5 lakh, we completed this one. And what the principle was completely wrong. I'm not denouncing what people are. They are great. People are great. But you have to sense the problem as what is the weakest point. And you attack at that point. Then you can see. We design a structure. No. start what is the actual process. You start one, you go on enlarge it, depending on the size. Okay, what do you want? So this was developed. Then you see, then my idea came to think. You see, we developed this systems. Some are what with the throw effect because Bell Ghaziabad, they developed this what you call laser system, but they can sold in the market. Okay, so because it is they sell it at 100 watt, but finally when it was giving about 10 watt. So I told them that I have spent money 100 watt, money for what you have done. Now, okay, I give that message to me, I will increase. Then my student, my most favorite student, Spartan. Both of us, because he has to run the computer. I don't know how to operate the computer. Okay, so anyway, we started to see Lazar Hardy in the corner. You can see Lazar Hardy. Okay, Lazar in the corner. Okay, you see, in a laid bed, you want to harden, you see, you can take a straight line along the feed diets. If the ley lines are in the feed direction, you get the minimum pixel. You can lay that on, make this one harden, okay, and the speed of hardening is in 50 millimeters per second with a laser of about 81. Then we see alloy, we deposit something and see that you can see the alloy. Then you see you will harden and you can see a layer is coming harden there. The other one is a micro groove which is formed which can carry the vertical lubricants. So this was the PhD work of our Partha. Okay. Anyway, we have drilled hole in silicon. You see, silicon to etch out about 10 micron, it will take about, I think 1 micron will take about 10 hours. I think 100 microns will take about 100 hours. But this is the machine, it is what you call high energy electrochemical reaction. We have drilled a hole which has taken in 2 milliseconds silicon hole. The third one is this was a problem for the satellite because they want completely round microballs. So you see, ball size is decreases, it is miniaturized as well as piston is reduced. So you use the Sasida principle, which was done by Partha Sahib, Partha Sahib and Asim Hamraj Chaudhary. We have published how the formula because if you take a pixelless boundary in a circular drum, then it will be completely spherical. So obviously we took a exercise of this thing. It will give a size because the minimum size is 3 particles will give the minimum size. And that depends on the particle size. So we have done that one. Then something in the selective sintering to deposit something on this. But the same machine can be used. So this is the future machine. In one machine, you can achieve many things. Anyway, so this was the thing. These are some of the projects which the students used to do. Because that students have to do. Anyway, this is a builder principle. Everybody see it's a micro robot. Feel like it. you can move a thing with 3 legs. Because you see, 3 legs means you can stay in any stability wise. Okay. And it says the device is actually there. It can look at this one. The resolution is you can go to nano level. And there is a hole in the top. And you can put the camera and take a surface topography in the nano level. But the moment what you do, you feel like you can see when we sit on a tool, our movements are different. How to move the body and all these things. This takes care. This is nano. And see, this some people should try. This is the thing, mathematics. This is algorithm. You see, in the operation theater, they want the needle to be bent in that direction so that you can give. You see, surgical needles are different type than the ordinary injection needle. What do we do? I have a remote control from a what do you call step thing. Then start going, then rotating, and we can bend. All of the larger beam and they bend. This was much more appreciated. I'm sorry that I missed that boy. MIT too. He's with MIT. And these are other things. Microbial development we started doing, several things. And the boy who did it, he's there singing my office. He works in a big company. Okay. And these are the people who have to. Then you see, yesterday is what today. You see, from this one I can go further. So this is a thing where you see, if you keep the thing, whenever you future, you think what has happened today. And what difficulty of well, after some time you can solve that. With this principle, I started developing microsystems. Microsystems is tabletop. Now, what is going towards the microwave? How long? Okay, I will scoop faster. We can discuss. So these are tabletop machines. You can read this one because they will be circulating this one. These are tabletop machines. Microsystems engineering started in COP. College of Engineering. After my retirement, I joined College of Engineering, Pune, where there are no PhDs, no MTech. Okay. So I better to use the undergraduate students because to develop one piece machine, I started doing, okay, one MTech students, you take 4 BTech students, 4 BTech material, you take, they have got a style, 4 BTech students have to be there. Okay, so 4 BTech students, you do 4 BTech students, they will have someone. We take one from second, third year, one from first year. Third year, second year, first year, third. So you see, these people are trained, 4 people are trained, and the line goes on gradually. The thing goes on. The student teaching is better. So this concept, you see, we started interpreting the past. Like, what does this? This is a micro drilling machine. That's a drilling machine. Okay. And all these things, the leather manufacturing is more. This is a what makes a slave converted it to a what a friction welding. Because you can do friction welding in smaller components. Because you see, you want to attach one knot with a gold tip or something about copper tape, you can do it and you can do it. These are using students so they can handle because 5 students have to be accorded. 4 to 5 students have to be accorded. So everything is there. that everybody can assist the project and individually approach the thing. Now, this is another drilling machine where I have seen. Now, and this is another thing. This is exposing forming. The hydroforming machine, what do I have? This is to make hot pacemaker valves. You want hot valves. Okay. So you have to process that forming because plastics cannot be, or elastomers cannot be hot. After some heat, if you give a high strain rate, so you have to go for explosive forming with the forming speed is here. So you used to do it. And we could do what we did, how to pressurize it. We take, I think in cylinders. Yeah, or I say, is the Japanese data mechanic. So anyway, so the company, they manufacture cylinders, they gave us a cylinder, and top one, we took from some other machine and did, and there was a plate is there is a small, what we call electrode inside, and we produce a spark, burn everywhere, and that vessel deforms this. And this is another small, what do you call, machine. And okay, anyway, the idea is, my idea, the Japanese concept, because we are going to a macro system, our business will be macro. So this type of technology, they have used all the machines. So they're in micro systems. That is much more higher. But what we say, the concept, we have got so many, and you can see in the picture and control all the machines, right? So that you can carry your factory, repair factory, along with you, and repair them on site and come back. That's Japanese. So, and my concept is you use larger base, and there's no need of going to this one. Anyway. And after coming to IT, Buddhism, I started developing this, that IT Buddhism, every life. So I developed the same machines, concepts. I get fluid because I actually didn't have anything. Let the fluids prepare for the future. So all these machines were developed one by one. These are the machines. These are the different machines. And this is a machine because this thing. And this is, see, macro hole using series. Using series. You take, you see, because here disposable items, how they can be reutilized. Because you see, in India, you see, we have insulin, people apply, they throw that. That is a very costly thing. You see, probably one will cost 900 rupees. The actual material is cost about 17 rupees. So many would say, why can't we use this one? That is about 16 micron hole. And let it finish. So you can use that one and drill a hole by electrojet principle. What I developed, I declared. So this is the wastage utilization and doing lots of small things. And this is a setup. We have got different setup for different purpose. Here in one ledger, we can do, here I can see it. There I go. I got a video. Anyway, that video is 75. Well, these are the people at different places who have elder. And you can see here, we take projects were done because there is no effect or effect. And all these people, they have done at different years, but 5 years of stay was these people, and you can see But these people, they have helped me. Professor Mahapatra and Haning Rai. They have helped me really as they have helped me. And you can see the last is a lady, past lady of difference. Okay. And is Mikey. He is now the director of our Mikey was Geo. He's married. No, he was working it because for this project, Lazar Milik, he has done milling in Lazar. So BMW, Bharat, Bangalore, is this Bharat milling machine, who does Bangalore. Huh?
CMTA.
That's same thing. Private company, but they're the best manufacturer. Anyway, so she's on them because they think that they can retrofit their milling machines with the laser and do it. Now she has come back to CTG. So she has taken third step because she has taken in there as a team because IIT Kharagpur were students were being practical there. Practical there. So she's now, I think, whether DGM or something, she's there. Anyway, this is my thing. And features, you see, for this thing, I'm telling everybody, because to read this thing, how to live a future and how to build up a mindset and all this thing and find us inspired thoughts. You try, please try to illustrate out. I always say the younger teacher before attempting anything. These 4 books will guide them, their mindset, everything, and then we feel to attempt anything. Okay? And let me see. And I give some quotes for this because impairment percent. If you become impatient, I want to do it in 2 days. Yes, you can't come in. What the thing? You have to give freedom to the student to take more time. Okay. So this is my family. We're working on a problem you might have seen. Preface, this is my family, and you see me now. You see me when I had the brain seizure. This is my family. I want to make my what do you call Nati to do this thing because none of this my daughter-in-laws are from different countries. One is American, one is people Chinese, Taiwan Chinese. Okay, but she is a fantastic doctor. Do free service. The company pays because it's German form. So she goes for free. Because the American percentage of child present only 80% of child are type 1, type 80.
Very good.
So we are doing service and both of them. One is in AI, he's a practical engineer in robotics, and the second one was with General Motors. Work is a doctor. Now he's consulting. What do you call? Korean company, automotive company. Anyway, she's working with a Korean company because he developed the watch which a blind person can use it. With everything. What is this thing? And we have developed the system. You can, my next attempt is you can read a book, even a blind person can read a book. The theory of all these things, the new technology, that non-controversial, I want to bring it to non-controversial business basic. Okay, thank you. I'm sorry, I've taken 20 minutes more
Not at all.
because
Hello.
So, I invite questions from the audience.
So,
That was a wonderful.
do you have any question?
Tripathi here. Tripathi here. I think I had heard Dr. Misra earlier. No wonder he had got the Lifetime Achievement Award from INA. And his work in Japan, other countries, also in IITs, and so many patent applications and actual patents. And this is a rare area where very few people in India really work and excel. We are very comfortable. I was in CPRI for a long time. Every kind of sensor there for application into the laboratory were they imported from outside. So I had made some request that time, participative cooperation from IITs and others to develop some sensors. And there, I think quite a few people who had done excellent work both in the defense sector and as well as the IITs in developing sensors, but they are not accepted by the commercial markets, particularly in bioelectronics sensors and instrumentations and management. But yes, I think they have their own importance, and some of the hospitals, some of the laboratories, they are using them. Maybe not the class of accuracy which others are doing, but then work is going on in that area. One thing I learned from Misra, he never thinks that nothing is unmeasurable. Everything can be measured. And he tells that everything which can be measured can be controlled. And everything which can be controlled, the excellence and quality can be improved. And any is there, the price will be accordingly fixed. So I think in this particular development of micro machines and nanotechnology oriented robotic applications and other things, there is a huge field coming up in India. I'm keeping track of all those promises which we are getting from people who are going to give collaborative support to us. I think people with Misra's talent, the government should be able to utilize it much better. And somebody looking into the technology, what we are getting from outside, the quality of technology they give to us, and whether it is worth paying that kind of money for the improvement and other things which you are getting from abroad. So I don't know whether this is being done, but then we should have such people who have got practical experience throughout their life in strategic positions so that they can guide the government properly. I have no particular question because all that he told was very crystal clear, and he has developed and made it work and patented, and a lot of people have been benefited. He has a very high respect from the students of his time, wherever he has worked. So thank you, Dr. Misra, for enlightening us with something. I think we are spending less and less time in laboratory. Nowadays, the professors don't go to laboratory. The students don't go to laboratory. I came to know during COVID, 2 years, all laboratories were sealed and closed. So that is not a good trend, a good practice in the country. I think we should show this lecture material to students so that they get the passion with which Dr. Misra explains his work. Nowadays, I don't see that passion in any professor talking about his work during his time. Thank you, Dr. Misra. Thank you.
So much. Anand Kumar ji, are you here? possibly yes.
Let. I have.
Any other question? Anyway. Madam Renu Sharma, please
Sir.
propose a vote of.
Sir. Thank you, sir. On behalf of INA Bhubaneswar chapter and our esteemed co-host, Shikshan Santan TMTP University, CSIR MMT Bhubaneswar, IIT Bhubaneswar, NISER Bhubaneswar, and IEEE Bhubaneswar, not subsection, is now section. I extend my sincere gratitude to Dr. P.K. Mishra for his inspiring lecture on an ounce of practice values more than tons of preaching. His insightful presentation truly justified its title, offering profound wisdom and practical relevance. Special thanks to Professor Damodar Acharya sir, the Honorable Vice Chancellor, Directors of IIT Bhubaneswar, CSRMT, NISER, esteemed fellows, Professor Ashok Tripathi sir, Sanat Mishra sir, and other faculty members and organizers for their support. And special thanks to Dr. Mishra for legendary insight. This is going to help us and inspire us to do further research. He has really opened the book of his life in front of us. In very short, I extend once again a heartfelt thanks to today's speaker, Professor Prasant K. Mishra sir. Thank you, sir. Thank you all.
One small thing. So this whole entire thing is recorded. Can we really have your permission to circulate?
I don't have any.
Okay, fine, absolutely fine. Thank you. And a small memento from our side will be sent it to you in due course. Okay. Thank you so much, sir. He is a perfect engineer, and that you could see, and if we can follow him even 10%, we can really do wonders. Thank you so much, sir.
One thing I'll say, he always involved the students in your thing. Try to, if you can involve the students and give credit to them. Because I always present in what you call in conference. And most of my publications are gone. On basic thing, I have gone to SIB or SIB publications. That 4 publications. And Manav,
Yes.
Manappa, optimization problem, he has given. And with him, Samuel.
Yes, sir.
So people say give freedom to the students. Previously, what happens in our checking, but the teachers don't give credit to everyone. Even in my presentations everywhere, I involved even a technician into my public. And my name is always the last. It's most of the public, the teacher, he's the first, then rest of the things. That's not correct. Anyway, I'm sorry for if I've done anything wrong. It is because of my age. Because I think in a different way.
No, it was okay, sir. It was
Okay.
Thank you so much.
Thank you very much.